We're going to go through your Chapter 10 study guide. Now yours should be complete. You're comparing your answers to my answers. When you are doing study guide 2 and when you're taking your test, you should have a few things ready to go before you start. You're going to have your calculator, you're going to have your note card. I didn't have a note card, so I just wrote all the formulas on a piece of paper. And I also have my notes here. Your notes are in your math notebook, but I have them off to the side in case I need them. I would also, when you're completing the test, I would also have study guides 1 and 2 next to me, so I have hints on how to do problems. Okay, 10.1. I can solve problems involving triangles. Find the value of x, then classify the triangle by its angle measures. Okay, so if I look back at lesson 10.1, we were classifying triangles by side lengths, equilateral, isosceles, scalene, and we were classifying triangles by angles, acute, right, and obtuse. And then down here, very importantly, it says sum of the angles of a triangle equals 180 degrees. We're going to need to know that information for this lesson right here. If we're trying to find the value of x and they give me angles, I know that the three angles are going to be equal to 180 degrees. So I'm going to add all three angles together and put it equal to 180 degrees. Okay, here I'm going to combine like terms on the left side of the equation. So my like terms are x and x, well 5x, 15 and 45. 1x plus 5x is 6x, 15 plus 45 is 60. Okay, it says find the value of x. Did that. This is one answer. Then it says classify the triangle by its angle measurement. So I need to go back and see what these angles look like. One angle is acute. If I multiply x by 5, 20 times 5 is 100. This angle is obtuse. And if I add x and 15, 20 and 15, I get 35, and this angle is acute. If you have one obtuse angle, that makes the triangle obtuse. Same process here. Set all the angles equal to 180. It doesn't matter the order in which you put the sides. Now I'm going to combine like terms. Notice I'm taking the signs out in front. Positive 4x, positive 5x, and positive 2x equal 11x. Negative 9 and 2 make negative 7. So this is one answer. Now I need to identify if this is acute, right, or obtuse. So I'm going to take my x value and I'm going to plug it into all three of these. 2 times 17 is 34. 5 times 17 plus 2 is 87, and you can use your calculator if you need to. 4 times 17 minus 9 is 59. I have all acute angles. That makes this triangle acute. Find the unknown side lengths of the triangle given the perimeter, then classify the triangle by its side lengths. So this time, I'm using these guys right here. It's either going to be equilateral, isosceles, or scalene. Okay, so I have three side lengths. I'm going to set them equal to the perimeter, 21. It doesn't matter the order in which you put the sides into the equation. 1x plus 1x plus 1x equals 3x. Find the unknown side lengths. They don't just want to know x equals, they want to know what each side is. So this is 6 meters, this is 6 meters, and this is 9 meters, because 6 plus 3 is 9. Two of the side lengths are the same. That makes this an isosceles triangle. And number 4, all three sides are x. So I'm going to set that equal to the perimeter. 1x plus 1x plus 1x equals 3x. Okay, so all three sides are 25 inches. And that means that this is an equilateral. .2, so I'm going to just find my 10.2 notes here. Let me shuffle through. Okay, so here are my 10.2 notes. I have them open next to me. We talked about what a polygon is, what a regular polygon is, convex and concave. And then we talked about how to identify polygons, and then different types of quadrilaterals. So these are right off to the side. Tell whether the figure is a polygon. If it is, classify it and tell whether it's convex or concave. If it's not a polygon, explain why. Number 5 is not a polygon because it has curves. Number 6 is a polygon. Classify it. So this has 1, 2, 3, 4, 5 sides. A polygon with 5 sides is called a pentagon. And then convex or concave. Because I can draw lines anywhere in this figure and it doesn't go on the outside of the figure, this is called convex. Numbers 7 and 8. To be very careful with this. Students are getting this wrong because they weren't using the information that they give us. Here, the information that they give us is that you have a set of parallel lines. One set of parallel lines is a trapezoid. Okay, and number 8, I see that 2 sets of parallel sides. I see that all 4 sides are equal, and there are 4 right angles. So if there are 4 right angles, all 4 sides are the same, and you have 2 sets of parallel lines, it's a square. .3, I can find the area of parallelograms and trapezoids. So now I have my note card next to me for all of those formulas. Number 9 is a parallelogram, so I'm going to use the area of a parallelogram formula. Plug in the information, and then state the answer. I want to see all 3 of these lines. Number 10 is a trapezoid. I guess I don't need to rewrite 10. So I use the trapezoid formula. Remember that your bases are the parallel lines. So 10 and 4 are your parallel lines. So those are the numbers that go inside of the parentheses. It doesn't matter if you put 10 or 4 first. So I'm going to solve inside of the parentheses. Half of 2 is 1. 1 times 14 is 14. 10.4, I can find the circumference and areas of circles. Find the circumference and area of the circle. Use 3.14 for pi. If necessary, round to the nearest whole number. So 2 answers here. Let's start with the circumference. Circumference has 2 formulas, depending on if they give you a radius or diameter. This problem gives me a radius, so I'm going to use the radius formula. And plug that right into my calculator. And round to the nearest whole number. And then there's only one area formula, that's pi r squared. So 3.14 times 3 squared. Round to the nearest whole number. Okay, this problem gives me a diameter, so when I'm finding circumference, I'm going to use the formula with a diameter in it. So 3.14 times 10 is really just moving the decimal over and rounding to the nearest whole number. There is only one formula for area. The area has a radius in it, so I'm going to have to cut this number in half to find the radius. So my area is 79 yards squared. 10.5, I can find the surface area of prisms and cylinders. Find the surface area, if necessary, round to the nearest whole number. So when we're dealing with surface area and prisms and pyramids, there's no formula. You just find the area of each surface and add them together. So I'm going to start with this rectangle out front. This is a 3 by 11. Oops, I forgot the formula. There are 2 of them. There's one in the front and one in the back, so I'm going to multiply this by 2. Save that number for later. Now I'm going to work with this rectangle here. This is a 7 by 3. And there are 2 of them, one here and one over here. So I get 42. Now I'm going to work with the top and the bottom. So I'm looking at this bottom one here. This is an 11 by 7. There are 2 of them. So I'm going to multiply 77 by 2. To find the surface area, I'm going to add all 3 of these together. Okay. The difference between this problem and this problem is now we have triangles. Make sure you are using the triangle formula when you're finding the area of the triangles. That's one of the biggest mistakes that students make, is that they use the rectangle formula instead of the triangle formula. 14 by 12. Area of one triangle is 84. There are 2 of them, so I'm going to multiply it by 2. Save that number for later. Now this triangle, this base, is an equilateral. So that means all 3 of these rectangles are going to have the same dimensions. That does not always happen. This triangle is not always an equilateral. 14 times 26 is 364. There are 3 of them. So I multiply it by 3. Sometimes if this is not an equilateral triangle, if it's an isosceles triangle, 2 of the rectangles will be the same and the third will have a different dimension. If this is a scalene triangle, that means all 3 of the rectangles will have different dimensions. When we're working with surface area in cylinders, there is a formula. So here's surface area, here's cylinder. I'm going to use this formula right here. Notice that the formula is using radius. So I'm going to plug in the information, 3.14 times the radius. They give us a diameter, so you have to cut that in half. Then plug this right into the calculator, 3.14, 8 squared. Plus 2 times 3.14 times 8 times 18. And they want us to round to the nearest whole number. Oh, I did something wrong here. I think I might have put, no, 8. Oh, I forgot the 2 out front. 2 pi. That's important. I'm just going to insert a 2 here. Oh, that's not right either. Let's start over. 2 times 3.14 times 8 squared plus 2 times 3.14 times 8 times 18. There we go. Round to the nearest whole number. Okay, same thing. Let's use the right formula this time. 2 pi r squared plus 2 pi r h. 2 pi. This time they give us a radius. I'm plugging in the information. 2 times 3.14 times 9 squared plus 2 times 3.14 times 9 times 18, and round to the nearest whole number. I can find the surface areas of pyramids and cones. Pyramids do not have a formula, so I'm going to find the area of each surface and add it together. There is only one rectangle here, so I'm not going to multiply that by anything. But there are 4 triangles. There are 4 triangles, so I'm going to multiply this by 4. So I'm going to add the 4 triangles and the 1 rectangle to get a surface area of 204 feet squared. And there is a formula for cones. Surface area cones, pi r squared plus pi r l. Once again, r stands for radius. They do give me a radius in this cone. The directions ask me to round to the nearest whole number when I'm finished. Okay, always reading the directions because now we're moving to volume. I can find the volume of prisms and cylinders. If necessary, round to the nearest whole number. When you're working with volume and prisms, there is a formula. Volume equals length times width times height. So 15 times 5 times 30. Plug it right into the calculator to get 2,250 centimeters cubed. Same with the cylinders. Cylinder has a formula. Volume equals pi r squared h. This is a radius. They do not give you a radius here. Make sure you cut it in half. .14 times 3 squared times 4 equals 113 inches cubed. Almost there. We're still finding the volume on the back. Here they ask us for a prism, a triangular prism, so I'm going to follow this formula this time. This stands for the base of the base, so we're talking about the triangle's base. But if you put the numbers in the wrong order, you're still going to get the right answer. I'm going to enter a half as 0.5 to get 600. Okay, we're still working with volumes of pyramids and cones, rounding to the nearest whole number if necessary. So I'm working with a rectangular pyramid, so I'm using this formula. The base is a 7 by 7, and the height of the pyramid is 8. So on this one, what I'm going to do is I'm going to do 7 times 8, the whole numbers, enter, and then divide by 3, rounding to the nearest whole number. This base is a triangle, so I'm using this formula. The base is a 9 by 7, and the height is 12. So again, I'm going to do the whole numbers first. 9 times 7 times 12, enter. Divide by 3, divide by 2, or because they're both in the denominator, it's the same as dividing by 6. Last problem. Now we're working with a cone. 1/3 pi radius squared height. 1/3 3.14. The radius is 3 and the height is 12. So 3.14 times 3 times 12. Enter. Divided by 3. Oh, I did something wrong. I forgot my squared. Let's try that again. 3.14 times 3 times 12 divided by 3 gives me 113.